Okay, so it's 11.5 continued. In this video we'll be talking about equations of planes. So let's first make an observation. Note 3 non-collinear points determine a plane. So I have a question here, why is this the case? So let me draw. So non-collinear means that the 3 points do not lie on the same line. So let me draw. So this whiteboard is a plane. So let me draw 3 points on this whiteboard here. Okay, so I put 3 non-collinear points. So these 3 points do not lie in a line, as you can see. I'm calling the first one P0, second one P1, third one P2. Okay, I claim that these 3 points completely determine this whiteboard. So I'm going to look at define the vector from here to here. Call that V1. That's going to be P1 minus P0. So let's call that V1 here. So it's my V1. And let's call the vector from P0 to P2, let's call that V2. So V2, let's have it here. So as I mentioned, V1 is P0 minus P1, sorry, minus P0, and P2 is P2 minus P0. So let me write that over here. So I wrote those over here. Now, if I cross the V1 and V2, it's going to produce a vector that's perpendicular to both V1 and V2. So it'll be up like this, the cross product. So let's note that here. So we're noting that V1 cross V2. So this symbol means orthogonal. So I mean, are perpendicular to V1 and V2. So it means if I dot V1 with this, it'd be 0. If I dot V2 with this guy, it'd be 0. Again, so the cross product would be sticking up out of the board here. Okay, now let's take another point on the plane. Let's call it P. So I'll put it, say, here. Call it P. So there's my P point right there. And now I'm going to form the vector between P0 and P now. Let me do that. I'm going to call it R. Sorry, I meant V. So forming the vector between P and P0. Okay, so note that vector V is going to be P minus P0. So let's write that down here. So my V is then P minus P0. But now my cross product V1 cross V2, again, is sticking up this way. It's perpendicular to my V1 and V2. But note also that it's going to be perpendicular to my V vector too. So I'll write that here. Okay, so we've noted that V1 cross V2 is also perpendicular to V because V is in the same plane as V1 and V2, and is yellow. This is a cross product vector, say it's perpendicular to V1 and V2, which would make it perpendicular to V also. Okay, so let's summarize what we have. So summarizing, so hence for any point P on the plane, we have our V1 cross V2 dotted with our V, where our V is P minus P0, is equal to 0. Okay, so we call the V1 cross V2 a normal vector. Let me write that here. Okay, so we call the vector V1 cross V2 a normal vector for the plane. Okay, so this guy up here then is the equation we'll be using to find the plane. So let's take a look at an example now. So I'm going to erase the stuff and write an example up here now. Okay, let's look at an example here. This is from practice quiz 1, number 4. It says find the equation of the plane containing the points 2, 7, 1, 1, negative 2, 0, and 2, 9, 3. So I'm going to label the first point P0, this one P1, and this guy P2. It doesn't matter how you label them, but I'm going to label them that way. The final answer will work out the same in the end. Okay, so we're calling this guy P0, this one P1, this one P2. So this is our equation of the plane right here that we have to figure out. So our V1 is defined to be P1 minus P0, or V2 is P2 minus P0. So we write these using these values here. So doing my P1 minus P0, so here's my P1, 1 minus 2, 0, then minus my P0, which is 271. So subtracting the x components, that'd be 1 minus 2, then it'd be minus 2 minus 7, 0 minus 1. Let me write the answer right here. So then I put this again, it'd be 1 minus 2, so it'd be minus 1, it'd be minus 2 minus 7, so minus 9, 0 minus 1, so minus 1. Okay, let's do our V2 now, so it's going to be P2 minus P0, so let me write it here. Okay, so that's my P2, so it's 293, and then minus my P0, which is this guy up here. Okay, so doing a subtraction, 2 minus 2, 9 minus 7, and so forth. Let me write the answer right here. So we get in 0, 2, 2. Now let's find our normal vector. So the normal vector is the V1 cross V2. So let me write it right here, my definition of cross product. So here's my cross product here, definition. So IJK, then putting my V1, and then putting my V2, this guy down here. So let's do the I component first. So it'll be minus 9 times minus 2, so minus 18, and then subtract a minus, so be subtract a minus 2, so we write it here. So we get this. Then moving to J1, so recall that J has a minus sign in front. There's going to be negative 1 times 2, which is minus 2. Then subtract that, which is minus 0 then. Be J, and then moving on to the K1. So it'd be minus 1 times 2, so it'd be minus 2, and it'd be minus 9 times 0, so minus 0. Okay, and simplifying these we get, so we get negative 16i, 2j, minus 2k. So this guy here is the normal vector. So normal vector. Okay. So now let's use our equation of the plane up here. We can now plug into that. Okay, before plugging in the p in the equation up here, just x, y, z, is going to be some fourth point on the plane. We have to find conditions on these x, y's, and z's. So implies then, let's look at p minus p0. So it's going to be then p0 is up here. So it's going to be x minus 2, y minus 7, z minus 1. Let me write that here. So again, how I got that was be x minus 2, so I got that. Then be y minus 7, so I got that. Then be z minus 1, that's how I got that. Now let's use our formula up here then. Okay, so our v1 cross v2 dotted with p minus p0. In our case, our v1 cross v2 is our normal vector up here, so write it here. Then dot it with our p minus p0, which is this guy up here. I'm using the I, j, k notation, so it'll be x minus 2i plus y minus 7j plus z minus 1k. So now we're going to dot this, so it'll be negative 16 times x minus 2, 2 times y minus 7, negative 2 times z minus 1. That needs to equal 0, so let's write it down here. So we get this then, so it'd be minus 16 times x minus 2, 2 times y minus 7, negative 2 times z minus 1. Let's now multiply these things in, so multiply the 16 in, negative 16 in, sorry, the 2 in here, and the minus 2 in here. So I'm going to write the result down here. So we get this then. Now let's combine some like terms, so the 32 minus 14 and the 2. That looks like it's going to be 20, so we just write down here. So we get this. And lastly, I guess I can divide everything by 2. That would make it a bit nicer, I guess, just to make the number smaller. We can divide everything by 2, because it looks like 2 divides everything. So let's divide everything by 2. Okay, so dividing everything by 2, you have then negative 8x plus y minus z plus 10 equals 0. So this should be the equation of the plane right here. And to check whether we got it right or not, the 3 original points should satisfy this equation. So let's check that. So I'm going to erase some things now and check that. So here's the equation of our plane that we're claiming is the plane anyway. So these 3 points, P0, P1, and P2 should lie in this plane, so they should make this equation true. Let's check P0. So let's check P0 that is on the, plane here, on the plane. So P0, the x is 2, the y is 7, and the z is 1. So we're going to plug those into our equation of plane up here, and it should make this equation true. So let's check that. So plugging x equals 2 in place of x, y equals 7 in place of y, and z equals 1 in place of z here. So we get this, and that's negative 16 plus 7 minus 1 plus 10. So that looks like it's going to be 0. So that checks out, because you get 0 equals 0 then. And let's check P1 next. So for P1 then, x is 1, y is minus 2, z is 0. We're going to plug those into our equation of plane up here, and it should make it true. So let's check that. So plugging those values in, so 1 in place of x there, negative 2 in place of y here, 0 in place of z here. So I did it here, and it ends up being 0 equals 0 again. So check it's on the plane. And lastly, let's check P2. So to check P2 then, the x is 2, the y is 9, the z is 3. So we're going to plug those into our equation of plane up here. Let me write down here. So plugging in, we get negative 8 times 2, so x is 2, plus 9 because y is 9, minus 3 because z is 3, plus 10. So you can check that becomes negative 19 plus 19 equals 0, so 0 equals 0, so check. So we've shown that these 3 points are on this the equation of this plane here, they're on this plane. So hence we did it right. So therefore this is our answer right here. Okay, so we're done with the question. Let's leave it there. We're also done with 11.5. Okay, so I'm going to stop it right here.